Someday, plants like those you see around you, trees, grasses, and flowers, may be used to fuel your car. Biofuels are a renewable fuel produced from the biological material of living or recently living organisms. For example, some plants can be used for biofuel, and they are renewable because we can continue to grow more plants. Much of today's gasoline is made from the fossil fuel oil. Fossil fuels are a non-renewable fuel formed by the decomposition of buried organisms from millions of years ago. Fossil fuels are non-renewable because they take millions of years to form, and we are using them faster than they can be made. Both biofuels and fossil fuels emit the greenhouse gas carbon dioxide when they are burned. Greenhouse gases trap the sun's heat in the atmosphere, which can lead to global warming and climate change. The major greenhouse gases in our atmosphere are carbon dioxide, nitrous oxide, and methane. When fossil fuels are burned, they release carbon that has been buried in the earth for millions of years. The carbon is released in the form of carbon dioxide. The plants used to produce biofuels, on the other hand, use carbon dioxide from the air to grow. So when they are burned, they should add only that same amount of carbon dioxide back to the atmosphere. This means biofuels, unlike fossil fuels, shouldn't add more carbon dioxide to the air when they are used. However, the way we grow biofuels may affect the total amount of carbon dioxide released to the atmosphere.
The thing that we want to make sure when we transform over to using biofuels is that the global warming potential, or something we consider in terms of the net emissions of greenhouse gases, are neutral. We don't want to be growing things that are contributing more to the release of greenhouse gases to the atmosphere than what we're actually taking in.
Today, corn grain ethanol is the leading source of biofuel in the United States. Corn grain ethanol is a plant biofuel made from the starch in corn kernels. However, growing corn grain to make biofuel can have negative effects on the environment. For instance, growing corn often requires a lot of fertilizer. When too much fertilizer is used, some of it ends up in streams, rivers, and lakes. This can lead to algae blooms, which can deplete the water of oxygen, causing fish and other organisms to die. Corn also can only be grown in the summer, so the soil is often left bare over the winter. This makes erosion of fertile topsoil more likely. Other types of biofuel may have fewer negative impacts on the environment.
This whole idea with biofuels started with corn, and unfortunately we know now that that's not really the best choice as we move forward, and that's considered a first generation. So we're looking more at things referred to as cellulosic biofuel cropping systems.
Cellulosic biofuel is ethanol made from the cellulose in the leaves and stems of plants, such as grasses and trees. Some examples of potential cellulosic biofuels are switchgrass, hybrid poplar trees, and even prairie. Cellulosic biofuels may help maintain Earth's ecosystem services. Ecosystem services are benefits that people receive from ecosystems. Just a few examples of ecosystem services are filtration of groundwater, maintenance of fertile soil for growing crops, prevention of erosion, regulation of climate, and even recreational pleasure. What would the growth of cellulosic biofuels mean for the Yahara Watershed?
If we transform the landscape from growing more corn and soybeans and dairy-based farm systems to growing things like switchgrass and miscanthus, which is behind me, that will undoubtedly change the way that the amount of fertilizer that's being applied to the landscape. We'll be taking very low diversity, high input cropping systems and replacing those with low input, more high diversity systems, hopefully, which would reduce the amount of agrochemicals that we would probably be applying to the landscape. In turn, that would hopefully reduce problems that we have with nitrate leaching into groundwater supplies, as well as with runoff of phosphorus and sediment due to the better soil holding properties of grasses across the landscape.
Research is being done at the University of Wisconsin to determine how growing crops for cellulosic biofuel will affect the environment.
I'm standing out at the Arlington Agricultural Research Station, affiliated with the University of Wisconsin-Madison, and I'm standing in the middle of the trial plots for the Great Lakes Bioenergy Research Center. This is where we're doing research trying to understand the impacts that planting bioenergy crops might have on the carbon cycle, the water cycle, and overall productivity when it comes to growing these for biofuels.
Before farmers begin growing cellulosic biofuels across the Yahara watershed, it will be important to determine the effects these crops will have on greenhouse gas emissions, as well as their impact on water quality and quantity. Let's talk. What do you think? Are cellulosic biofuels a good solution to our need for a renewable fuel?